What if I told you there's a secret language that runs our world? A language that computers, mathematicians, and even your favorite apps use every single moment of the day to make sense of everything? Well, today we're going to learn its basic grammar. This is the key to seeing the hidden patterns in, well, pretty much everything. Let's jump in. I mean, think about your day. You're sorting things all the time, right? You put your favorite songs into a workout playlist, you group your groceries in the cart, you even sort your friends into different chat groups. We are all natural-born organizers. Well, it turns out there's a formal name for this art of grouping. It's called set theory. And yeah, it sounds a little intimidating, but trust me, it's not. It's just the rule book for how we organize information. It's the magic that lets a search engine actually find what you're looking for. So, here's how we're going to break it all down. First, what a collection even is. Then, the number one rule you have to know. After that, we'll see how to combine and compare these groups, how to figure out what's in and what's out, and along the way, we'll see how this stuff pops up everywhere. All right, let's start at square one. To speak this new language, we've got to learn the basic words, right? The nouns. And in set theory, there are really only two you need to know to get started: sets and elements. So first up, a set. This is just a fancy word for a collection of things. That is literally it. Think of it like a box or a folder on your computer or just a list where you've gathered a bunch of stuff together. For instance, this right here is a set of fruits. And you see those curly braces on the outside? Think of those as the box. They're just a signal that tells us everything inside belongs together in one group. Simple, right? Okay, so what about the individual things inside the box? We call those elements. So if the set is your favorite playlist, then each individual song on it is an element. So looking at this, the whole collection of art supplies, that's our set. And each individual thing, the scissors, the tape, the pencils, each one is an element. That's all there is to it. Okay, now that we know what a set and an element are, let's get to the first big rule for how these groups work. It's about counting, but there's a really important twist. This concept is called cardinality. Let's look at this super simple set. It's got 3 colors in it: red, yellow, and blue. Now, if I asked you how many items are inside this set, what would you say? You'd say 3. And you'd be totally right. The cardinality, which is just the official term for the size of the set, is 3. Easy enough. But this is where things get interesting. Now, take a look at this group. We've got Greg, Martha, Tim, Ted, and then, Greg and Ted show up again. At first glance, you might think there are 6 things in here. So what do you think? What's the cardinality here? We see 6 names, so it's got to be 6, right? Nope. The actual answer is 4. And the reason why this is true is the single biggest, most important rule in all of set theory. And here it is. In a set, every element must be unique. Sets just ignore duplicates. So even though Greg and Ted are listed twice, the set only counts them one time. This is absolutely crucial, because for a computer, the question isn't how many times is this here, it's is this here? Yes or no. Sets care about what's in the group, not how many times it appears. So we've got our nouns, sets and elements, and we've got our main grammar rule: no duplicates. Now let's learn some action verbs. These are the things we can do with our sets. First up are 2 of the big ones: union and intersection. Our first verb is union, and you can spot it by this U-shaped symbol. Just think unite. A union is when you take 2 collections and merge them. You just pour everything from both into one big new set. And of course, you always follow that number 1 rule: toss out any duplicates. Visually, the union of set A and set B is everything you see in both circles combined. Here's a perfect example. Let's say you want pepperoni and mushrooms on a pizza, and your friend wants mushrooms and olives. The union is the final order: 1 pizza with pepperoni, mushrooms, and olives. We only list mushrooms once. Okay, next up is intersection, which looks like an upside-down U. Now, if union is about combining everything, intersection is about finding only what's shared. It's the common ground, the stuff that exists in both sets at the same time. You see that small part where the circles overlap? That's the intersection. And this is an incredibly powerful idea.
I mean, every time a social media app shows you your mutual friends, it's actually running an intersection. It's comparing your list of friends with someone else's list and showing you only the names that appear on both.
Okay, so we can combine sets and we can find what they have in common. But what if we want to do the opposite? What if we want to filter things out or see what's left over? Well, that is where difference and complement come in. The difference, written as A minus B, is all about subtraction. You start with everything in set A, and then you just remove anything that's also in set B. What you're left with are only the things that are unique to A. Online stores do this constantly. When they recommend products, they're often taking the set of all products and subtracting the set of products you've already looked at. And finally, we have the complement. Now, this one's a little different. It needs a boundary. We call that the universal set, which is just everything we could possibly be talking about. So the complement of A is simply everything inside that universe that is not in A. For example, if your universe is all recipes on a website and set A is recipes with peanuts, the complement is every single other recipe that doesn't have peanuts. You're basically asking for everything but what's in set A. And that's it. Sets, elements, and the 4 basic operations. This isn't just abstract math, is it? It's a lens. It's a way to see the world. It's the logic behind your music recommendations, your search results, and how data is organized pretty much everywhere. So the next time you filter a spreadsheet or search your email, remember these simple, powerful tools. You know the secret language now. So the only question is, what will you do with it?